Welcome to Unit 4, Lesson 2, Graphs of Sine, Cosine, and Tangent x. We want to know what the graphs look like because this will help us figure out what the derivative of sine and cosine and tangent should be. Let's start with sine. We know that sine of x, well, sine of 0 is 0, so we start at 0. As the angle increases, here's our triangle. We know that in this example, here's theta. Sine of theta, sine is opposite over hypotenuse. Therefore, sine of theta in this example is y over 1 because this is called the unit circle. The hypotenuse is always 1. So we can see that as the graph, as theta gets larger and larger, y gets larger and larger, and x gets smaller and smaller. So sine x must be going up right here. When theta gets to 90 degrees, y is 1, so sine of 90 degrees is 1. Sine theta can never get bigger than 1. As we keep going on the unit circle, sine x gets smaller again. When we get to theta equals 180 degrees, well, y equals 0. So sine of 180 degrees is 0. And then sine becomes negative. It becomes more and more and more negative. When we get to 270 degrees, sine is at the smallest. And then it gets bigger and bigger and bigger until it gets back to 0. Okay? So if we look at the graph of sine x, it gets bigger and bigger and bigger until you get to 90 degrees, and then smaller, and then negative, and then goes back to 0. And if we keep going in a circle, this is called a periodic function. It keeps going like this. One important thing to remember is sine starts out at 0, and the slope is positive at 0 because it's getting bigger and bigger and bigger. Okay, that's sine. Next, let's look at cosine, the graph of cosine x. Let's use blue for cosine. We see that in our triangle, cosine theta, that's the adjacent over hypotenuse. Adjacent is x, hypotenuse is 1, so cosine theta is just x over 1 in this example. So when x is 0, well, when the theta is 0, cosine theta is just 1. So cosine starts out at 1. And then, unlike sine gets bigger, cosine gets smaller when we go to 90 degrees. And cosine of 90 degrees is 0, and it becomes negative, and so forth. Let's look at the graph. The graph starts out at the cosine theta starts out at its maximum when theta equals 0. It gets smaller and smaller and smaller. Past 90 degrees, it becomes negative. Past 180 degrees, it starts increasing again. Cosine of 270 degrees is 0, and it goes back up to the maximum. So that's the cosine theta. So what's the difference between sine and cosine? A quick way of checking is if we ignore horizontal shift. Sine starts out at 0, cosine starts out as maximum. 0, maximum. Finally, tangent. With tangent, let's use orange. So we see that with tangent is opposite over adjacent, which is y over x in this example. When theta is 0, y is 0, and x is 1. So tangent of 0 is also 0. So tangent also starts at 0. As we go up to 90 degrees, tangent goes up really quickly. Whoa, it goes to infinity. Why? Because tangent of 90 degrees is actually undefined, it's infinity. Why? Because y becomes 1 and x goes to 0. In fact, it could be positive or negative infinity because on the other side, it starts at negative infinity. Like that. So the graph of tangent looks like this. It starts out at 0, it goes to the positive infinity, and then it comes back from negative infinity back to 0 and so forth. So the graph of tangent looks very different from the graph of sine and cosine. Okay. To summarize, sine starts at 0 without any phase shift. Cosine starts at the maximum, and tangent, it looks a little different. Okay. This will help us in the next video, in the next lesson. Let's look at some graphs. Here's the first one. We see that the graph, here's the equilibrium, the 0, the middle point. We see that the graph starts at the middle. So that means this has to be some sort of sine function without phase shift, sine x. Okay. How much do we go up? We go up by 2. That's called the amplitude. So the function is not just sine x, it's 2 sine x. Furthermore, we start at 3. The y-intercept is 3. So this function has to be y equals 2 sine x plus 3. To summarize, we see that sine x, we know it's sine because it starts at 0. If we have something like 5 sine x, that means we're multiplying by 5. If we have something like sine x plus 3, that means we're moving the whole graph up by 3. So this is y equals 2 sine x plus 3. Next graph. This one. Okay. The middle is at negative 2. I'm going to use blue for this one. So let's switch to blue. The middle is negative 3. Sorry, negative 2. We know it's the middle because we can go up, go down by the same amount. So we know this starts out at its maximum, so we can describe it as a cosine function. But it's not cosine x because we're going from the middle, negative 2, we're going up 3, 1, 2, 3. So the amplitude is 3. So this should look like y equals 3 cosine x. Finally, the middle, the y-intercept is negative 2. So the graph of this should be y equals 3 cosine x minus 2. Y equals 3 cosine x minus 2. To summarize with cosines, we start at maximum. Y equals 4 cosine x just means we're multiplying the y by 4. Y equals cosine x minus 3 just means we're moving the graph down by 3. Okay. One last graph. Let's look at this one. Well, this one looks like a tangent. So it should look like y equals tangent x, something like that. But it's not exactly y equals tangent x. Why? Because we see that when x is 0, y is 1. The y-intercept is 1. We move the graph up 1. There's a translation of 1. So we can say y equals tangent x plus 1 for this graph. Okay? So again, graphs of sine, cosine, tangent look like this. This will help us with our next lesson. That's it.